Children, now we are going to learn about cyclic structure of glucose. See, already we have learned that open chain form of the glucose. So Fisher identified that open chain pentahydroxyl aldehyde structure of glucose. Um, uh, ordinary aldehyde, ordinary aldehyde, glucose will not react with the sodium bisulfite. Skips test, not oxidized by tolerance reagent or filling solution. So this behavior could not be explained by the open chain structure. These are all tests for aldehydes, reaction with the sodium bisulfite, Skips test, pentacetate derivative of glucose by tolerance reagent, filling solution. But this and all could not be explained by open structure of glucose. So, glucose is found to crystalline in two different forms. One is alpha form, the other one is beta form. Alpha form at 419 Kelvin, beta form at 423 Kelvin. So, in order to explain these, it was proposed that one of the hydroxyl group reacts with the aldehyde group. There are 6 carbon atoms. In the 6 carbon atom, OH5 OH present, one of the OH reacts with the aldehyde group to form a cyclic structure or hemiacetal structure. So the achiral aldehyde carbon becomes into chiral one. See, this is the structure of glucose. 3, 4, 5, sixth one is CH2OH. Third carbon is OH. This should not be forgotten. Then others H, 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 OH, OH, OH. Here any one of the OH should react with the aldehydic oxygen to form a cyclic structure or hemiacetal form. So here in aldehyde group C, you see C double bond OH, here one carbon. This is not the chiral carbon. Chiral carbon means carbon should be bonded to 4 different groups. This is the achiral carbon. But in cyclic structure, this is achiral means not symmetric. So this leads to 2 isomers, that is called anomers. The 2 anomeric forms of glucose, that is called alpha form and beta form. That is C1 carbon can link with the carbon atom 5. Among these two there is a linkage. Why the other OHs can be linked with the aldehyde group means there is angle strain. And also becomes unstable. This means less angle strain, the molecule also will become stable. Because of that, there is a linkage between carbon atom 1 and carbon atom 5. Now I will show how it forms. See, this is aldehyde group C double bond OH. Then this is the 5th carbon. In between 3 carbons present. Now why there is a linkage here? See, here there are 2 lone pairs in oxygen atom. So this is here, this oxygen is more electronegative. So this bond shifted here. So this becomes negative. The carbon becomes positive. Now this lone pair, one of the lone pair can be shifted to oxygen. So this positive has gone. Positive gone, so carbon becomes neutral. Now, so this bond now. So after donating 2 electrons, this become positive, this oxygen. So this bond can be shifted here. So this positive has gone, becomes neutral. Then this H comes out with the positive sign. That hydrogen shifted here. So now see what's the structure. C H. Hydrogen shifted here, COH, this side H. Fifth carbon, CH, 1O. That can be linked with the first carbon. This form is called as hemiacetal form. Now this can form two isomers, that's called anomers. See, the others all same only. Second, third, fourth. Third means OH, HOH, HOH, then CH2OH, sixth carbon. Similarly, one more isomer. Here the OH is kept in the right side, right. So alpha D glucose. If it is kept in the left side, H, fifth carbon. Third OH, H. So HOH, HOH, CH2OH, OH in the left. So beta D glucose, alpha D, beta D, capital D. Capital D means left or right, beta D glucose. So this can be kept in a cyclic structure, that is called Haworth projection formula. See how it can be drawn. Totally 6 carbon atoms. So O should be in the right corner. First carbon, second carbon, third carbon, fourth carbon, fifth carbon, and sixth carbon. Similarly, one more structure I can draw. See, whatever kept in the right side should be in the down, left should be in the top. So this is the first carbon, second, third, fourth, fifth, sixth, first, second, third, fourth, fifth, sixth. So now we can write alpha D. Here, whatever kept in the right should be in the down. So here OH, OH, H, OH. So I will write down you can write OH, OH, H, OH, OH, H, OH, 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 H, OH, down I wrote. Then left side H, H, OH, H, 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 OH, H. Then next one more H left. CH2OH always in the top. So sixth position. One more H left here. That should be here. This is alpha D glucose or beta D. You see, HOH, HOH, down. HOH, HOH. Left side OH, 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 H, OH, H. Sixth position CH2OH, one hydrogen here. This is the anomeric forms. So the rotation of pure, this is alpha D, this is beta D. Only this OH differs. So the specific rotation of pure alpha and beta D glucose are 112 degree and 18.7 degree. When a pure form of any one of these sugar is dissolved in water, the interconversion of alpha D glucose and beta D glucose takes place, and with a specific rotation of plus 53 degree. This phenomenon is called as mutarotations. So sugar which differ in the configuration at asymmetric center, that is called as epimers. So anomers means different, epimers means different, differing in configuration. differing in configuration. So the process by which one epimer converted into other epimer, that is called epimerization. That is galactose converted to glucose by this manner in our body. See, all having same formula only. Sixth carbon CH2OH, CH2OH, CH2OH. This also same only. See here, HOH, HOH, OHH, fourth carbon, there is a change. Here it is same only. Second carbon you say OHH, here HOH. Here second carbon differs. These are called C2 epimers. These are called C4 epimers. So epimer means only arrangement of atoms in space get differ. That is differing in configuration.